NASA is preparing for a historic return to the moon with Artemis 3, the first crewed lunar landing in over 50 years. This mission is more than a symbolic return. It's the start of building a lasting human presence on the moon. NASA's goal is to learn how to live and work on another world, paving the way for future missions to Mars. The Artemis program marks a bold new era, relying on advanced technology and private partners. For the lunar landing, NASA chose SpaceX, known for its reusable rockets and ambitious engineering. SpaceX is developing a special version of its Starship, called the Human Landing System, or HLS, to ferry astronauts from lunar orbit to the surface and back. This partnership signals NASA's trust in private industry for critical mission components. Artemis 3 aims to do more than plant a flag. It will launch a new era of lunar science and exploration. Astronauts will explore the lunar South Pole, a region believed to contain water ice in shadowed craters. Discovering water could revolutionize lunar missions, providing resources for life support and fuel. The crew will spend days on the surface, collecting samples and conducting experiments impossible from Earth. The world will watch as the first woman and first person of color step onto the moon, inspiring a new generation. The Starship HLS must be proven safe and reliable for this high-stakes journey. The mission is ambitious, pushing the boundaries of spaceflight and international collaboration. Every step must go right to ensure the astronauts' safe return. The success of Artemis III could define the future of human space exploration. All eyes are on NASA and SpaceX as they attempt this historic lunar expedition. The plan to get Starship HLS to the moon is complex, far more than just launching a single rocket. Starship HLS is massive and needs a huge amount of propellant, far more than one launch can provide. SpaceX will first launch the empty lander into Earth orbit, where it will wait for multiple tanker starships to arrive. These tankers, designed solely to carry fuel, will rendezvous with HLS and transfer propellant in orbit, a process never attempted at this scale. It could take over 10 tanker flights to fully fuel the lander. Each launch and docking must be flawless. Any failure could jeopardize the mission. Once fueled, Starship HLS will head to lunar orbit. Meanwhile, Artemis astronauts will launch separately aboard NASA's Orion capsule and SLS rocket. Both vehicles will meet in lunar orbit, where the crew will transfer from Orion to Starship HLS. This requires another precise docking maneuver, far from Earth. The multi-step plan introduces many risks: multiple launches, complex refueling, and challenging landings. Transferring cryogenic propellants in space is a major technical hurdle yet to be perfected. The tall, heavy Starship HLS also poses landing challenges on the moon's uneven surface. Each added step increases time, cost, and risk for Artemis III. The mission's complexity is its greatest vulnerability. While NASA and SpaceX tackle these challenges, others in the space community are reimagining the lunar lander. Tim Dodd, known as the everyday astronaut, proposed a bold new concept: the stubby Starship. Dodd, a respected science communicator, analyzed the current plan and saw opportunities for improvement. He questioned whether a smaller, lighter lander could simplify the mission and reduce risk. The stubby Starship would be designed solely for lunar landings, eliminating unnecessary hardware for Earth re-entry. By shedding mass, the lander would need far less propellant, potentially halving the number of tanker flights. Dodd's idea quickly gained attention, sparking debate among space enthusiasts and professionals. His proposal highlights how fresh perspectives can drive innovation in space exploration. The stubby Starship challenges the status quo, showing that good ideas can come from anywhere. It's a reminder that rethinking the basics can lead to smarter, safer missions. The stubby Starship introduces several key changes to the lunar lander design. Most notably, it's much shorter, about half the height of the current HLS, achieved by removing the upper propellant tanks and re-entry hardware. This drastic reduction in mass means the stubby Starship needs far less fuel for its mission. Fewer tanker flights, perhaps only 4 or 5, would be required, saving time, money, and reducing risk. The shorter design also improves landing stability, lowering the center of gravity and making it less likely to tip on the moon's uneven terrain. The crew cabin, now closer to the surface, allows for a simpler, safer way for astronauts to exit, possibly even a staircase instead of a long lift. These changes make the lander more efficient and reliable for lunar operations. The stubby Starship is purpose-built, no extra weight, no unnecessary systems. Its design directly addresses the biggest risks of the current plan: complex refueling and unstable landings. By focusing on what's essential, the stubby Starship could transform lunar exploration. It's a streamlined solution for the unique challenges of the moon. The concept demonstrates how targeted design can improve mission safety and efficiency. Simplicity in this case is a powerful advantage. Comparing the original Starship HLS and the stubby Starship reveals a trade-off between capability and simplicity. The full-sized HLS is versatile and can deliver massive cargo, but its complexity and risk are high. It requires many tanker launches and faces stability issues on the lunar surface. The stubby Starship, by contrast, is lighter, needs fewer launches and offers better landing stability. Its main drawback is reduced cargo capacity, limiting the amount of equipment per mission. However, for Artemis III, where crew safety and mission success are paramount, the stubby design's simplicity is compelling. Fewer launches mean fewer chances for failure and lower costs. The easier crew access and improved stability further enhance safety. The stubby Starship is a specialized tool for early missions, while the full-sized HLS may be better for future, larger-scale lunar operations. Choosing the right vehicle depends on mission priorities. Safety and simplicity now, greater capacity later. The stubby concept could be the stepping stone to a sustainable lunar future. History shows that simplicity is often the key to success in space exploration. The Apollo program thrived on robust, straightforward systems, an approach still relevant today. The stubby Starship embodies this philosophy. Less mass means less fuel, fewer launches, and fewer chances for things to go wrong. Simplifying the mission architecture directly increases safety and reduces cost. Cutting the number of launches from over 10 to under 5 saves time and money. A shorter, more stable lander is safer for astronauts, especially on the moon's rugged terrain. Easier crew egress reduces risk, eliminating the need for complex elevators. Simpler missions can be flown more often, accelerating lunar exploration and base building. Lower costs and risks make frequent missions possible, opening the door to rapid scientific progress. The stubby Starship could make lunar exploration more sustainable and ambitious. By focusing on efficiency, we can achieve more with less. The lesson: the smartest solution isn't always the biggest, but the one best suited to the job. Simplicity could be the key to a new era on the moon. The stubby Starship proposal has sparked valuable debate and innovation in the space community. It shows the power of open discussion and fresh ideas, even from outside traditional aerospace circles. Right-sizing vehicles for specific missions, rather than building one-size-fits-all giants, may be the smartest path forward. For early lunar landings, a dedicated, efficient lander could be the key to success. As ambitions grow, larger vehicles will play their part, but incremental, mission-focused design is a sustainable approach. The principles behind the stubby Starship, efficiency, simplicity, and adaptability, will shape future missions to the Moon, Mars, and beyond. Progress in space comes from challenging assumptions and embracing innovation. The future belongs to those who build not just the biggest, but the smartest machines for the job.